So what's different about this one? They have negative angles, right? The angles inside are negative. Okay, well, which identities do we have that deal with that? Right. If you go down to the bottom of that, right here, you've got the even and odd identities. That's the only place you see these negative angles. So we remember that the only two that are considered even are the cosine and the secant, because secant is 1 over the cosine. For even functions, the cosine of a negative angle equals the cosine of a positive angle. They're the same thing. You can just get rid of the negative. For all the rest, they're odd functions, which means it's kind of like take the negative outside the function. So you could take that negative and it becomes negative sine u or negative cosecant u. So if we look at the functions that we've got in this one, that's not right. The cosecant, that's 1 over sine, so that's the odd. So this is the one we can pull out a minus in front. The secant is 1 over the cosine, so that's the one where we just get rid of the negative because it's even. That's the substitution you would make with using those identities. So this becomes negative cosecant of x over secant of x. So now we don't have any more negative angles. We still need to make this look like a cotangent. How might we do that? No. Yeah. Okay, you could do that. You could say cosecant is 1 over the sine, and secant is 1 over the cosine. And then what? When you divide by a fraction, it's like multiplying by the reciprocal, right? So I can rewrite this as negative 1 over the sine of x times cosine x over 1. Right? So there's your cosine over sine, which is cotangent. Now you might have also at this step, right? If it's a cosecant in the numerator, it's a sine in the denominator. If it's a secant in the denominator, there must be a cosine in the numerator. And we've done that before, but if it helps you, you could go through all that process.